Can tell you before that they really hate this class, okay? Because my students in general don't like my class. I don't know why, but okay. But if you have a background in chemistry, okay, only a little background in chemistry, you will understand this class, okay. But at the beginning, maybe it just scare you because this is something look very difficult. But if you understand the basic, okay, only the basic of the reaction, believe me, I promise you can understand all the class. But organic chemistry, okay, in organic chemistry there are a lot of reaction, the chemical reaction, a lot of reactions. Even me, I cannot memorize all the reaction. This is impossible. Okay, so maybe you can think that you can memorize, okay, all the reaction, but it's not true. You don't need to memorize, but you need to understand. Okay, if you understand the concept of the reactions, okay, you can understand what happens after. Okay, because in chemical reaction, okay, you have the substance which react together and give the product, the corresponding product. Okay, it's impossible to memorize the starting material and all the products. This is impossible. So I recommend that you need to understand what happened. So even if I change the starting material or I change the condition of the reaction, you can understand what happened. Okay. So, okay, my name, okay, everybody knows Lect.Saiwan, okay? If you have any questions after class or before class, do you know where is my office? Anybody go to the second floor of our department? On the second floor, okay, there are a lot of office of the lecturer, but my office is the first office on the second floor. Okay, if you go up, do you know the room 301? Yeah, okay, directly downstairs. Okay, so the first office. If you have any question, you can ask me. Yeah? Okay. The problem is I used to go very fast. Okay, so it's not good, I know. But this is my written, my teaching written. So usually I go too fast, but I will try to go slowly this year. But even I try, maybe it's not slow enough that you can understand or follow my class. You can stop me anytime you want. Okay. Okay, so you can stop me. Okay. So what is the industrial organic chemistry? So it's just the name, you know. But in this class we study about the chemical reactions and also the organic chemical which involve in the chemical industry, okay? Because you are or you will be chemical engineering, so it's possible that in the future you work in the industry, okay? And in chemical industry, we produce a chemical, or we use chemical to produce another material. Okay, so first we produce the chemical compound, and second we use a lot of chemical. So we think that it's useful for you that you learn a little bit about these chemical, that you can see which are the important chemical compounds in chemical industry, okay, how to produce these chemical compounds, or how to convert these compounds to another important chemicals. Okay, so in this class, I focus on the chemical reactions. Okay, a lot of chemical reactions, how to produce the corresponding chemical compounds. And we choose some important chemicals from the chemical industry. Of course, there are lots, so we cannot talk about them. So all the substance is not possible. So we choose only some important compounds. Okay. So I will start from the overview of my class for this semester. Okay. Okay. I never come here before. Okay. So we focus on the production. Okay. Production. Production of some chemical compound. We can say just some chemical in the industry, okay? So, when we finish this semester, you will see the connection, okay, between these compounds. We just group in different chapters, but they are all linked together, okay, because one component is the starting material of the other components, etc. So when you finish all these chapters, you can see the connection between them. So you can draw the flow chart and you can connect them together, okay? But at the beginning, maybe you don't see the connection, it's okay. And maybe you don't see the relationships between them. So the first chapter corresponds to, we start from the smallest hydrocarbon compound. Because this is organic. This is organic chemistry, okay? So we focus on the organic compound. So you see the difference between organic compound and inorganic compound. What is the difference? Organic compound, what does it mean, organic compound? I will not talk about the inorganic compound in this semester. We focus on only organic compound. So what is the meaning of organic compound? Just say, I know Ajahn Jindarat must tell you everything about the organic compound, right? Yeah. Organic compound. What is the difference in organic and organic? Okay. There are a lot of detail, okay? But it's easy to explain that organic compound must contain mainly carbon, okay? And what else? Hydrogen, yes. Carbon, hydrogen, oxygen, and sometimes nitrogen, and sometimes halogen, okay? So X means halogen. So you will see this substance during this semester. So we focus on hydrocarbon, okay? So not only hydrocarbon, of course, because hydrocarbons are not very active. When we talk about the reaction, we will focus on the functional groups, okay? What does it mean, functional group? Give me some example of functional groups. Alcohol, for example. So we will focus on the functional group. So this is an alcohol, OH, acid, for example, or ester, for example, aldehyde, ketone, etc. Okay? We focus on hydrocarbon compound with or without functional group, or sometimes in the presence of halogen compound also. Okay? So we choose the important chemical compounds in industry only. Okay, because this is the industrial organic chemistry, right? So we start from the smallest hydrocarbon compound. So what does it mean, smallest? Give me in your opinion, which is the smallest hydrocarbon? Methane is the smallest one. Huh? So, for example, methane. This is hydrocarbon. 1 carbon and 4 hydrogens. Okay? CH4. This is methane. So methane, do you know how to produce methane in industry? Do you produce methane? Or we don't produce methane? No, we don't produce methane. We just separate methane from the natural gas. Okay? So So methane is the smallest one, but I will not talk about the production of methane because it's not the production, it's just separation, okay? So, the first chapter, okay? So the first chapter, we focus on what we say C1 unit. Methane is also a C1 unit because C1 unit means the chemical, okay, the chemical which contains only one carbon. So methane is C1 unit, but as I say, I will not talk about the production of methane. So give me another C1 unit, which is not methane. Methanol, yes. For example, methanol. Okay, this is methanol. Okay, we produce methanol, okay, in industry. So I will start from the production of methanol. Okay, methanol is very important. The most important C1 unit compound in industry. When I say the most important, maybe it's because of the production scale, because we produce a lot of methanol each year. We can convert methanol to a lot of compounds. That's why it's important, okay? So the first chapter contains methanol. What else? So I put one functional groups. This is carbonyl group, okay? So which carbonyl group compound which contain only one carbon? What is the name? Do you know? Only one carbon. This is ketone. If you have only one carbon, it cannot be ketone, but it must be aldehyde, right? Because you have only one carbon. So the name of this compound is formaldehyde. Okay, so methanol, formaldehyde, for example. Okay, and what else? Hydrochloric acid, for example, in this chapter, and the hydrocarbon which contain halogen compound. Okay, so I put X here. This is, for example, chloromethane. Okay, so this is C1 unit. So we will start from C1 units. Okay, and from C1 unit, zoom out. So maybe this week or next week, I will talk about the production of C1 unit, starting from methanol, okay, followed by formaldehyde, hydrogen cyanide, and chloromethane to finish the C1 unit. So the second chapter, you can see this in the handouts, okay? I have all the overview, okay? So for the second chapter, another group of the chemical, very important also. This is called olefin. Okay, so for the second group, so now we don't focus on the number of the carbon anymore. Okay, we don't move from C1 to C2, no. This time we focus on the number of double bonds. Okay, so olefin means alkene. This is the same. This is alkene. Okay, but in industry we don't call alkene, but we call olefins. Okay, so the second chapter I will talk about the reactivity of double bonds. Okay, and how to produce olefin in industry. In general, olefins or alkene could be produced from the cracking of alkane. Okay, so you get alkane from petroleum or natural gas, and you crack, you produce double bond in hydrocarbon. Okay, and olefin is very important because olefin is the starting material of polymers. Okay, so polymer or plastic, we convert olefin to plastic, okay, or polymer. So this is why olefin is very important in industry. Okay, of course, you cannot live without any plastic anymore. So in your daily life, you use polyolefin each day. For example, plastic bag or plastic bottles, they are all come from the olefins. Okay, so olefin and we convert to polymers or polyolefins. So this is why we focus on the production of olefin. And next, we oxidize olefin. Okay, so the next chapter focus on the oxidation of ethylene. So this oxidation products called ethylene oxide. This is very important also. So ethylene oxide. Okay. I hope that I can finish this oxidation product of ethylene before midterm examination, but I'm not sure. It depends on the speed. Okay. And next one is oxidation product of propylene. This is very important too. Okay, propylene. So you have two important alkene in industry, which are ethylene and propylene. Okay. What is the difference between ethylene and propylene? They contain double bond, but yes, the number of carbon. Okay. I think everybody know about the nomenclature of the organic compound with Ajahn Jindarat already. Okay. So ethylene means the alkene which contains 2 carbons, and propylene 3 carbons. Okay. How many double bonds for propylene? Only 1 double bond. Okay. And next, we introduce the functional group to the chemical compound, which is alcohol. Okay. So we will start to the production of alcohol. Okay, in industry, how to produce alcohol, for example, ethanol, propanol, butanol. Okay, and the higher compound. So higher alcohol means the very big molecule, long chain of hydrocarbon which contain OH group. And the next chapter is vinyl halogen. Okay, vinyl halogen. So what does it mean, vinyl? Vinyl means also double bonds. Okay, so vinyl halogen means double bond which contain halogen atom. That's all. Vinyl halogen could be converted to polyvinyl halogen compound. For example, polyvinyl chloride, PVC. Yes, or PVDF, PTFE. So this is just a short name. Okay. So vinyl halogen is the starting material also of the plastic. Okay, but different plastic from this group. So you can convert vinyl halogen to also plastic or polymer. Okay, so this is why it's very important in industry. And the last one, okay, this is a very big group of chemical compound. This is called aromatic compound. So we will finish with me. I mean, after you come back to Ajahn Jindarat. Okay, so what does it mean, aromatic compound? So this is very different from another groups of the chemicals that you can learn before, because cyclo, yes, but cyclohexane, this is aromatic or not? No. Okay. Aromatic compounds mean the chemical which contain rings. Okay. This is a ring, for example. We call ring. This is a ring. But not all the ring could be aromatic. Okay. This ring must have double bond in the rings. Okay. So when you have 3 double bond in C6, this is the C6 rings. What is the name? Benzene. Okay. For example, so benzene is the one of the most important aromatic compound industry. Okay, you can produce aromatic compound you can separate aromatic compound from petroleum or from coal. Okay, so you will see how to produce aromatic compounds in industry and how to convert aromatic compounds to another secondary products. Okay, so do you have any questions? So this is the overview, okay, of this semester with me. So you see, after the class, you will see the connection between them. Okay, so finally, you will be able to explain all this stuff, how to produce them and how to convert them to another compound. So how to produce the chemical product? First, you have to know about the chemical reactions. Okay. Okay. So today, I think it's better to start by learning about the basic or the concept of the chemical reaction first. Okay. This is why I put a small introduction chapter before the C1 unit. Okay, so I don't start directly in C1 unit compounds, because before, I think 3 years before, I never have this introduction chapter about the chemical reactions, and I found that students get confused after. So before last year, I just start from C1 unit, okay, and I teach the chemical reaction at the same time, okay, when we need. But sometimes students get confused about these reactions. So today, I give you a short introduction about the chemical organic reaction first. Okay? So if you don't understand the class of today, you have to ask me now. Okay? Because after today, next class, I will use this concept and apply this concept about the chemical reaction in the class. Okay? So if you don't understand, you can ask me today. I can explain in detail. Okay? Questions? No questions? Okay. 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 So, okay. So this is the outline. But 8 weeks is to optimize. I mean, it's not impossible, but I have to go very fast if I want to finish in 8 weeks. So 8 weeks is not possible, I think. Okay. Okay. So oxidation products, mean alcohol, hydrogen, and aromatics. Okay. So you can see aromatics compound. We need 2 weeks at least, because it's very the reaction of organic compound is just completely different from another group of the compound. This is why we have to spend more time on organic compound. Okay. So before, so do you know the handbooks that I use? Okay, I use a lot of handbooks. I have always the question about which books I use. Okay, I use also I search also in internet. Okay, and also you can use all the organic chemistry handbook because I don't use the detail, not too much in detail anyway. So it's just a concept. Okay, so you can use any organic chemistry book. But for the industrial part, I use the first one. Okay, I'm not sure that you can find the first book in PDF. I don't think so. But we have maybe 3 copies here that you can maybe photocopy them. Okay, but in the book, in the first one, there are too much detail in the first one. So I don't recommend that you read all the detail. It's too much details, because in this class I reduce a lot of detail in the book. Okay, and I just choose some reaction only and some compounds only, because we don't have enough time. Okay, so first I want to talk first about the reaction. Okay, So let's meet the reaction. We focus on reaction in organic chemistry. Okay, only in organic chemistry. So do not confuse with the inorganic reactions. Okay. When we talk about organic chemistry, so you see you have the reaction, we set equation, okay? This is the reaction equilibrium or equation, whatever. On your left, you have some different substance or compounds, okay? On your left, these are the starting materials. We call starting materials, or sometimes we call a precursors. Okay. So it's just the vocabulary. Is the starting materials. You can have more than 2 starting materials, okay? 2, 3, 4, 5, whatever. So sometimes you can see this word, precursor. It's the same, precursors, also starting material. So we convert starting material by reactions, okay, to the product. So on your right, so these are the products. So you can have 1 product, 2 products, whatever, but you have main products. But we have also byproduct. So what is the meaning of byproduct? Just the vocabulary. What does it mean byproduct? So you produce products and byproduct. We can say sometimes secondary product, okay, for byproduct. Byproduct means it's not the primary product. They are not what do you want at the beginning, okay? It's not the main product, but it is produced somehow, okay? You cannot avoid. So it's not the product that you decide. This is why we call byproduct or secondary product, okay? So main product should be called a primary product, and byproduct sometimes I can call secondary product. Okay, so we don't know which one, Okay, so when you have the starting materials, okay, this starting material could be a molecules, okay, that we call compound, complete molecules, or sometimes it could be only ions. They are also starting material, not only compounds. Not only the complete compounds, okay. So we have another vocabulary to call this, we say atom, ion, molecule, whatever. But in the reaction, we call them species, okay. So when I use the word species, it's not the same meaning as biology. In chemistry, the word species means compound, molecule, ions, or whatever occurred in the reaction at that moment, we call species. Okay, so don't confuse about this vocabulary. Okay, so you can see that reactions means different species react together. Okay, and for example, the last one, AB. When we have A, B connect together by the black lines, what is the type of the bonding in organic chemistry? It's the black lines. Single bond. What is the type of the bonding? We have different type of the bonding, right? Covalent bonding. Yes. So what does it mean, covalent bonding? This is the basic of chemical reaction. You have to understand the meaning of covalent bonding first. If not, you cannot understand the reaction. So what is the meaning of covalent bonding? You have different bonding. Ionic bonding, for example. What does it mean, ionic bonding? Ionic. completely. Okay, I want to explain about the bonding first. CHM103. Okay, so the basic is all atoms are connected by the bonding to create a molecule, or this is what we call compound. Okay, but you have different type of the bonding. Just say AB, okay? AB are bond by, if I use the black straight line, it means covalent bonding. So, covalent bonding means A and B share 2 electrons. Okay, they share. So, co means share. Okay, valence means electron valence. Okay, A and B share valence electron together. Always you have 2 electrons for one covalent bond. No more, no less. Okay, always. So, if I use a straight line, 2 means 2 electrons for this bonding. But sometimes, okay, A and B don't have the same ability to attract electrons. This ability is called electronegativity. What is the meaning of electronegativity? Yes, as I say, electronegativity means the ability to attract electron. Okay, so it could be covalent bonding if A and B don't have too much different ability to attract electrons, so they just share. Okay, but sometimes A and B don't have the same ability or the same electronegativity, so sometimes B get all the electrons. Okay, 2 electrons are with B atom. So in this case, B become negative and A is positive. So this is called ionic bonding. Okay, but in organic chemistry, we focus on covalent bonding. Okay, so it just happens when we share equally the covalent electron. So this is A and B. How reaction can occur? For example, you have A, B covalently bonding, and C, D also a covalent bonding. To produce, we don't know the product. Okay. The reaction can occur if we break the bonds. Okay, so you have to break the bond first. So first you have to know how to break these covalent bondings. Okay, and once you break the bonding, you can create the new product. Okay, so first break the bond, and second create the new bonding, so you can get the new products. Okay, for example, A and B is broken, C and D is broken, so we produce AC or BD. But it could be AD and BC also. So which one? We don't know, right? But all this could be explained by the breaking of the bond. Okay. So if you break this bond, one atom can get all the electrons together. Okay, or it's not the case. So it depends on the breaking of the own bonds to explain which product you get finally. Okay. So we will start on the how to understand how the reaction can occur. So how the bond is broken and how to create the new bonding. Okay. So in order to understand how reaction occurs, okay, in organic chemistry, we use what we call a mechanism of the reaction. You will see what does it mean. So, in organic chemistry, okay, what does it mean mechanism in organic chemistry? In organic chemistry, mechanism is something which explains how electron move, okay? So, the transfer of electron. Yes, because the organic reaction can occur only if you have the transfer of electron from one species to another species to get the new bonding and to create the new compound. Okay? So in organic chemistry, we focus on the movement of electron from one atom to another atom. Only, okay. So this is the transfer of electrons. Okay, so you will see how to draw the mechanism of the reaction. Most of students don't understand because for me it's not difficult, but for you maybe it's difficult. Okay, but if you try to explain the basic of the mechanism of the reaction, once you understand the transfer of electron between atoms, you can understand what happened in the reaction. Okay. Okay. So the transfer of electrons, for example, you have atom A and B, okay? B contains 2 electrons, for example, just for example, and B contains 1. What is the meaning of this stuff? This is a free room, free orbital, okay? So when B atoms have a free orbital, okay, and A has a lot of electrons, okay, A, B meet up so they can exchange electrons and get the new bonding. For example, we can use the arrow. Okay, this is the 2-head arrows because we have 2 heads. In organic chemistry, when we use the arrow, okay, in mechanism means the transfer of 2 electrons. 2 electrons. Okay. So it means that in this case, when we react A and B, in this case, 2 electrons, 2 valence electrons of A, these 2 electrons move to B. Okay, so what happens after when 2 electrons move to the free orbital of B? You get the new bonding because, okay, the 2 electrons of A will be shared, okay, and you get a new covalent bond. So you have this kind of stuff. Okay. So these 2 electrons comes from A, but after the transfer of these 2 electrons, you have new single bond between A and B. Okay, so this is the basic drawing of the organic mechanism. Okay, the organic reaction mechanism. So the 2-head electron, okay, means the transfer of 2 electrons. Okay, it's possible to draw a transfer of 1 electron. Yes, we call a 1-head arrow. Okay, so you can just write like this: the transfer of 1 electron, for example. Okay, so this is what you have to memorize. That's all. How to draw the mechanism of the reactions. Okay. Questions? The question is, this is necessary to understand the mechanism. Of course, if you don't, you have to memorize all the reactions, so it will be difficult. But if you understand the mechanism of the reaction, so the transfer of electron between the starting material, you can understand which products occur, what is the byproduct, for example. So I recommend that you try to understand the mechanism, but it's not necessary, of course. Okay, finish? Yeah. Okay, so now I hope I can start. Okay, so how the chemical reaction can occur? Of course, first you must have the conditions between the different species, okay? Ion or molecule, whatever, they must collide together. So when two species have impact, okay, you have two choices. Reaction occur or they just separate after collision. So it depends on what? It depends on the activation energy, for example, and also the kinetic energy of the system. Okay, some reaction occur very easy because activation energy is very low. So energy from collision, this is called kinetic energy, is high enough, okay, to conquer this activation energy. So the reaction can occur. But sometimes when the reaction have too high activation energy, or the reactants are too stable, for example, even collisions, after collision you don't have anything, it's possible also, okay? So it depends on the condition. Of course, it depends also the concentration of the compound, for example, because when you have the concentrate solution, okay, they have more chance to collide, right? Because they are more, the population is high, so they can meet very easy. So when we use the very dilute solution, the rate of the reaction is very low, and you get a very small product only. So it depends on the condition, okay? Temperature, for example. I think everything you study from kinetic before, kinetic of the reactions. Okay. So also the orientation of the collisions. Orientation means the place or the angle where the molecules meet or connect together, okay? So everything, energy, orientation, everything. But of course, in this class, I don't focus on the kinetic of the reaction. I only focus on how the reaction can occur, just in case you have enough energy, okay, to conquer the activation energy already, okay. So, I introduced the new vocabulary again. Inorganic compounds, for when the reaction occurs, the reaction can occur only when you have two different types of the species, okay. One species is rich in electrons, and another one is poor in electrons. In this case, you will get the transfer of electrons between them. You get the reactions. But if you react the compound which is rich in electron and rich in electron together, they don't do anything because they are already rich. Okay, so no exchange. Or poor in electron species with the poor electron species react together, no reaction occur because no electron to exchange. So inorganic reaction, the reaction can occur only when you have two different species, one rich in electrons. Okay. Okay, so the species with a lot of electrons, this is a rich electron species, okay, react with a poor electron species. So rich and poor. We have the vocabulary very specific for this type of the species. Okay. For compound or ion rich in electrons, we call nucleophile. Okay. And the species which is poor electrons, this is electrophile. Okay. Phi means love in Latin, and then like or love in Latin. Yes, Latin means love or like. Okay. So electrophile means the species which love to react with electrons because they don't have. Okay. And nucleophile means atoms which love to react with the nucleus, because nucleus means proton, neutron, right? Without electron. Okay. So it means the nucleophile like to react with the species which has no electron. Okay, that's why we call it like this. Huh? We use Nu, okay, and E. So you must have two different species to get the reaction. For example, which are the nucleophiles? Which are the species with a lot of electrons? So it's easy. The first one is anion, for example. Anion, for example, this one. Okay, halogen ion, for example. Or it could be another ion, carbon with a negative charge. For example, oxygen with negative charge. For example, they are rich in electrons. Okay, so this is why we call nucleophiles. Okay. So this is the first group of nucleophile. Okay. The second one, for example, nitrogen with a lone pair. Do you know what is the meaning of the lone pair? Lone pair means when you have two unbound electrons. Okay. But nitrogen does not have any ion, any charge. Okay, with a lone pair. Because they don't have the excess of the electrons. I think everybody knows how to count the charge and lone pairs. Do you know how to write the Lewis structure? I hope so, because it's the basic. If you don't, it's very problematic. Nitrogen with lone pair, oxygen with lone pair, or halogen with lone pair, also whatever. So nucleophile must contain negative charge or lone pairs of electrons. Okay. How about the electrophile? Electrophile is the opposite. So it's something with positive charge, whatever, with a positive charge. So all the positive charge are electrophile. And something with free orbital. So of course, if you want to know how many lone pairs, how many free orbitals, what is the charge, you have to know how to write the Lewis structure of the compound first. Everybody knows how to write the Lewis structure. You have to learn this before, right? Lewis structure. Yes. Okay. Okay. So this is the free orbital. This is the structure of free orbital. Sometimes you can draw like this or like this, whatever. Okay. For example, here you have nucleophile. Okay. I don't identify the atom. Nucleophile which contain one lone pair. Okay. So lone pair means two black points. So because one is one electron. Okay. When I put two electrons, this is a lone pair. Lone or lonely is the same. It's the same meaning. It means the unbound electrons. Okay. In general, you have nitrogen, oxygen, halogen, which contain a lone pair. So, in organic reaction, for example, you have the transfer of this lone pair of the nucleophile. Okay, so 2 electrons move to the empty orbital. So you can represent by using an arrow. So this is a two-head arrow. The arrow in organic reaction mechanism must start from the electron. Okay, this represents the way how electron is transferred. So of course, the direction of the arrow is very important too. So this arrow means the transfer of this electron start from nucleophile. Okay, and nucleophile donate electrons to electrophile. Donate means give. Okay. So what happens after this transfer? Okay. So this electron will be shared between nucleophile and electrophile. So you get the new covalent bonding. How about the charge? Why nucleophile become positive, for example? Because nucleophile donate 1 electron. Okay. 2 electrons move. Okay, but only 1 electron is donated completely to B because 2 electrons are shared. Okay, so in this case, nucleophile become positive because nucleophile share completely 1 electron to electrophile. So when you have a covalent bonding, when we count the charge, okay, we don't count the shared electron. You count only the electron which is with the atom. Okay, so in this case, this electron is not with nucleophile anymore. So this is why electrophile becomes zero charge. Okay, because before this is positive one. Okay, so I know that you have learned everything before from the first year. If you know how to draw the Lewis structure, how to count the charge. But I know that you forget everything also. But don't worry. Okay, so in organic reactions, okay, we start from the breaking of the O-bond, right? So if you want to get the correct product, okay, first you have to know about how the bond could be broken first, okay, because you have different types of covalent bonding. Sometimes the breaking could be the single bond. I focus on single bond first. Single bond means 2 electrons. Okay, 2 electrons each share. Sometimes when you break the bond, you break in the middle. I mean, so 2 atoms separate after the breaking. Okay, and 1 electron goes to 1 atom, and another 1 electrons go to the second atoms. Okay. In this case, you have what we call a homolytic cleavage. In organic chemistry, it's just vocabulary. Cleavage means break. Okay. When I say bond, the cleavage of the bond, it means I break the bond, for example. Okay. Homolytic. Homolytic means the bond is broken equally. Okay. So this happens when you have 2 atoms with the same electronegativity. Okay. For example, carbon single bonds. For example, when you break carbon single bond, it's the same atoms. Okay. So 2 electrons of single bonds are shared equally by 2 carbons. So once you get 1 electron, they separate. Okay, they are separated. 1 electron go to the first carbon, and the second one go to the second carbon. This happens also when you break halogen compound. For example, XX, for example, 2 chloride atoms. Chlorine, we call chlorine. Okay. Cl, for example, this is 2 electrons. Chlorine atom is not very stable, okay? Because chlorine has very high electronegativity. So this single bond is very weak. Okay. So when you cut by heating, for example, you can break this bond easily by only heating. You heat, so you get 2 chloride radical. Okay. This is called radical or free radical. I don't know in Japanese, huh? In Thai we just say okay? Free radical is the vocabulary, okay? You have to memorize. Radical means atoms contain one unbound electron. This is called radical. It's different from the lone pair because lone pair means 2 unbound electrons. Radical means 1 unbound electron. I think there is only way to produce a radical. You can produce a free radical by breaking the old bond. Okay, and you have to break it homothetically. Okay. For the second case, when you have 2 atoms with a different electronegativity, okay, carbon, for example, bonds with halogen atom. In this case, carbon and halogen, which one is higher in electronegativity? Halogen, of course, okay. Carbon has very low electronegativity, yeah? So, when you break this single bond between carbon and halogen, you produce carbon positive charge and halogen negative charge because 2 electrons of the single bond go with halogen atom, okay? So, carbon lost 1 electron. This is why carbon becomes positive. So this is the formation of this species is called cation, and a negative species is called anion. Okay. So sometimes you can produce carbon with negative charge, but this is very difficult to produce carbon with negative charge. Because carbon negative charge could be produced only when carbon is bonded with a metal. Because in general, metal has lower electronegativity than carbon. Okay, so when you start from this compound, this is called organometallic. Carbon bond with metal and you break this bond. Okay, this is heterolytic cleavage. So you don't break it equally. So you produce carbon negative charge and metal positive charge. Okay. Okay, so how to induce this breaking, how to start the reactions. So you will see by drawing the mechanism. But you have to know which type of the cleavage, okay? Just to know the product that you produce after, okay? So I think I almost finished about the vocabulary, okay? So you know what does it mean nucleophile? Okay, so what is the meaning of nucleophile in chemical reaction in organic chemistry? Nucleophile means the species which is rich in electron, for example, anion with negative charge or a lone pair. Okay? Electrophile react always with nucleophile. Electrophile means the species which is poor in electron. For example, atom with positive charge or free orbital. Okay, and cleavage means the breaking of the bond. Okay, you have 2 types of the bonding cleavage, heterolytic or heterolytic, which produce free radical, okay, or anion or cation. So all these are the basic vocabulary that you will see, okay, all this semester. So today I want to talk about the basic organic reactions, okay. In general, we have a lot of reactions, really a lot of, but you can categorize this reaction in groups. Okay. The first group of the reaction is called substitution reactions. Okay. When you substitute or replace atom by another atom. And the second one is elimination, addition, and the last one is rearrangement reactions. But I will focus on the three first: substitution, elimination, and additions. Okay. You have seen this before or not? Substitution, elimination, addition from high school maybe, right? So I can go very fast, right? I don't know if you take a break, you know. Do you take a break? What time? Do you want? Okay, you have a coffee shop there. Okay. ร้านแดงไม่มีแล้ว Okay, so 10 minutes, okay? Okay, so the first reactions, this is the common reaction, okay? This is called substitution reactions, okay? So substitution reaction means you have two reactants. Okay, what is the meaning of substitution or substitution? What is the meaning? Replace, okay, replacement, everything. So substitution means, I just say, I don't identify the product. You just use A and B and C. Yeah? You have A, B, okay, two atoms. A connect with B, react with C, okay? C substitute B on A, okay? So B is replaced by C. So the product will be AC. This is the product of substitutions. So what happened with B? B will leave the molecules. Okay. So B is leaving the molecules. So in this case, B is called a leaving group. Okay. So this is only the vocabulary. Yeah? B is a leaving group. So in substitution reactions, okay, this reaction can occur when you have a good leaving group. If you don't have a good leaving group, the reactant cannot replace. Okay, so you must have the good leaving groups. So which kind of the good leaving group? This is the question. Okay, the question is how leaving groups can read the molecules. It depends on the strength of this bonding. Okay, so the first thing to do is we have to break the bond between A and B first, right? So in some case, when you have a very strong single bond or strong covalent bond, substitution reaction cannot occur. Okay. So you have to know about the strength of the bonding. Okay. So which single bond is very strong? For example, carbon or carbon hydrogen bonding. Okay. In the case of carbon, it's better to use a visualizer maybe. Okay, for the substitution reactions, okay. A, B is the starting material. B is called a leaving group. Okay, I use Lg for the leaving group. Okay. So this bonding must be weak enough to be broken. If not, you cannot substitute. Okay. So you meet with C, you break the bond. Okay, so you substitute B by C, and C here, and B just leave the molecule. Okay. So which type of the B groups could be? For example, a good lipid group. In this case, you can have heteroatom, such as oxygen or halogen. Okay? Why oxygen and halogen? Because the bonding between carbon and oxygen and carbon and halogen are very weak. Okay, this is why it's easy to break. Okay, they are weak because you have too much difference on electronegativity between carbon, oxygen, and carbon, halogen. Okay, so when you have the heteroatom on the hydrocarbon, the substitution reaction can occur. So the substitution reaction can occur for alcohol, okay, and alkyl halide. So this is possible in the case of alcohol or what we call alkyl halide because of the strength of this bonding is low. Okay, this is why you cannot substitute carbon. For example, if this is carbon, for example, this is impossible to substitute this carbon by another compound or another species because it's very difficult to break this bond. So no substitution possible. Okay, for example, if you have this static material, okay, CH, and you react with, for example, chloride, negative charge, okay? You cannot substitute methyl by chloride. This is impossible because you cannot break this bond. So it's impossible, okay? But if you have methanol, for example, you want to substitute by chloride. This is an alcohol, right? Alcohol. The substitution reaction can occur because this is possible to break. Carbon-oxygen bonding is quite weak. Okay, this is too strong. Okay, so you can substitute by producing alkyl halide from alcohol. Okay. So this is alkyl halide. We call me chloromethane. Okay, this is C1 unit, and this is also C1 unit. You will see this reaction in the first chapter when we talk about the C1 unit. You can convert methanol to chloromethane by using the substitution reactions. Okay. Okay. Questions? Okay. So the starting material for the substitution reaction are in general alcohol, okay, or alkyl halide, because OH group and halogen atom are good living group, so they can quit or leave the molecules and replace by another atom. This is why. So hydrocarbon, in the normal hydrocarbon, is impossible because carbon single bond is very small. You cannot break it easily. Okay? In the normal condition, but in some condition you can break carbon single bonds. But anyway, it's not a substitution reaction. Okay? When you break these bonds, in general, this is for example, you can break this bond when you want to produce olefins by cracking process, but not by the normal condition of substitution reaction. It will be another reaction. Okay. Okay. So the most important substitution reactions is what we call nucleophilic substitutions. Okay. So what is the meaning of nucleophilic substitutions? The most important substitution reaction. Nucleophilic substitutions SN reaction, this is the most important. It's very common reaction. You can see this reaction anywhere. Okay, you will see a lot of SN reaction in this semester. You have seen this before, but you don't know. Okay, so you know the word substitution, you know the word nucleophile. So what does it mean, nucleophile substitution? You substitute the lipid group by nucleophile. That's all. Okay, so nucleophile substitution, that. CH is possible, yes, but not by chloride anion. CH bonding could be broken also, but this one is broken and you can produce a radical. Okay, so radical means carbon with one electron and hydrogen with one electron. Okay, CH, you mean CH bonding, right? Then here, CH bonding. You can substitute hydrogen, but not by anion. Okay, you can break this bonding. Okay, what is the type of the cleavage? CH, in your opinion, because hydrogen is not heteroatom. So how about electronegativity between carbon and hydrogen? They are so different or they are quite the same? Ready? Carbon and hydrogen. This single bond is strong or weak? Carbon hydrogen. It's very strong. Okay. It's almost the same strength as carbon-carbon. Okay. Because hydrogen has almost the same electronegativity as carbon. Okay. So you can break this bond, but you must produce two radicals like this. Okay, this is possible. But so in this case, you cannot react with chloride negative charge, not like this, because you can react negative charge with electrons. No, because in this case, you have to reach electron species, they cannot react together. Okay. So in this case, it's possible to react chloride, but not chloride negative, but chloride radical. This is possible. So it's different now. So you can react chloride radical with carbon radical to produce chloride methane. You say chloromethane. Okay. This is also a substitution reaction, but this is called a radical substitution. Okay. So it's different now. Questions? So for radical substitution reactions, I will talk about this reaction once when we talk about the production of chloromethane. Okay, because this is the main reaction for the production of chloromethane substance in the first chapter. It's good that you ask me now. So you can see that it depends on the reactant also. It could be a radical or it could be an anion or cation. Okay, because the reactants induce the cleavage of the bond, right? So when I say the reactant induce the cleavage of the bond, I mean, so when you have this one, okay, you react with chloride radical. You have the same starting material, but you react with chloride anion. So it depends on the reactant that the reaction can occur or not. So we focus on how electron could be transferred. Okay, chloride anion means you have two electrons. because negative charge means 2 electrons. This is 2 electrons, okay? So in this case, you have 2 electrons which can donate, okay, which can be donated to another compound by chloride. So chloride negative charge or chloride anion can donate 2 electrons to another compound. This is the principle. Chloride anion want to donate these 2 electrons to another atom because chloride want to get back a 0 charge, okay? When atom or molecule have positive charge or negative charge, they are not stable. They want to stabilize the charge. So the reaction occurs in the direction of how the substance can get the 0 charge back. So chloride have 2 electrons, free electrons, which are very mobile and can move. So chloride negative want to donate electron to another compound, right? Okay. So let's see how carbon can get these 2 electrons. Is it possible or not? We'll see. Yeah. The same here. You have chloride with 1 electron here. This is a radical, right? Is it possible that chloride can react with CH bonding? This is possible because you can break this bonding. So when you break this bonding, you have homolytic cleavage because carbon and hydrogen have almost the same electronegativity. Okay, so this breaking is homolytic. Okay, so carbon become carbon radical. Okay, but in this case, if you want to react chloride with CH bonding, okay, carbon have to accept 2 electrons of chloride, right? So what happened for this one? You donate, okay? Chloride donate 2 electrons to carbon. Okay, but how about carbon? When you have to do the transfer of electron, remember carbon is tetravalent. Okay, so what is the meaning of tetravalent? You have only 4 arms for carbon or 8 valent electron only, okay? So carbon cannot have more than 8 electron. Valence electron, 4 arms is the maximum for carbon. Okay, so once chloride donates 2 electrons to carbon, you have the new bonding between carbon and chloride, right? Sure. So you must create the new bonding between carbon and chloride. This is the principle of the reaction. When one species donates 2 electrons to another species, you get the new single bond, always like this. So these 2 electrons will be shared between carbon and chloride. So you get the new bonding between carbon and chloride. But carbon will have 5 arms. It's not possible, right? So what we have to do? You have to break the old bond. Okay, so the problem is which bonding. For example, you create the new bond between carbon and chloride. So you have to break this bond. You have to, because carbon cannot have 5 arms. It's impossible. So the 2 electrons of this single bond have to go with hydrogen. Okay? Okay, so this one. And hydrogen become negative. Okay. Okay, this is called hydride. But it's not normal for hydrogen to become a negative charge. Because first, you have no reason that hydrogen recover all the electron here. Because hydrogen and carbon have the same electronegativity. So hydrogen does not have more ability to attract electrons. So hydrogen have no reason to recover our electron here, in this case. Okay, so this is not stable, okay? Because hydrogen is bad leaving group. Okay? So this mechanism is not possible. Okay. So So this is the good living group, oxygen, halogen. Now you can know why oxygen and halogen are the good living group because they have high electronegativity. Because living group leave the molecule and recover all electrons. That's why once the single bond is broken, okay, because 2 electrons of the own bond must go with the living group. So when you have high electronegative atom here, the mechanism is logic, okay? But hydrogen with 2 electrons is not logic because hydrogen has low electronegativity. Okay, but for this one, this is completely different. It's not the substitution, the normal substitution. Now it's different. You have only 1 electron here. This is called radical. Okay, radical is not stable. 1 electron is very unstable. Okay, so because electron is more stable, 1 electron is coupled with another electron. Okay, a pair of electrons is stable, but not 1 electron. So this is why when you have a free radical, okay, occur in the reaction, the radical must react. It has to. Okay, a free radical are very unstable, so a free radical will induce the cleavage of another bond because they are not stable. So chloride has already 1 electrons, okay? So chloride needs only 1 electron more. So this is why chloride radical induce the breaking of this single bond. But this cleavage is homolytic or heterolytic in your opinion? Homolytic. The homolytic cleavage could be induced from a free radical. So that's why, okay, you have this bonding. And hydrogen radical will couple with another free radical of chlorine in the reactions. You can produce free radical of chloride by chlorine. You produce a lot of free radical, okay? So you produce HCl as byproduct in this case, okay? So for the first reaction, you will see this reaction in the first chapter when I talk about chloromethane. Okay, we focus on radical substitution. Okay, but for now, I want to focus on nucleophilic substitution. Okay. Okay, so SN reaction. Okay, anybody have seen this SN reaction before? Only one. Ready? Okay. So just forget about the radical substitution, okay? Now we focus on SN reaction. It's very common reaction in organic chemistry, so it's very useful if you understand it. So in SN reaction, okay, of course, it occurs with carbon because this is organic reaction. Carbon must contain heteroatom, oxygen or halogen. Yeah. So it must be alcohol or uncured halide. Okay. X could be bromide, chloride, iodide. But how about fluoride? Uncured fluoride can undergo the nucleophilic substitution or not? Fluoride is an exception, okay? Fluoride is a halide, but fluoride is not a good living group. The carbon fluoride single bond is very strong, okay? Compare with carbon bromide single bond or carbon chloride or carbon aldehyde. Carbon bromide, carbon chloride or carbon aldehyde bonding are very weak because these three halogens have high electronegativity. So these halogens attract 2 electrons, okay, towards them. But how about fluoride? Fluoride is also very high electronegative, okay? Fluoride is the highest in the table. Do you know why? They explain, you can believe or not, but the explanation is why CF bonding is strong, because the size of the atom are equivalent. Okay, bromide, chloride, iodide are very big atoms. So this is why the bonding between carbon and such big atoms are very weak, because they don't have the same size, and the overlap of the orbital are not good enough. Okay, but for CF bonding is as strong as CH bonding, so they are not very reactive. Okay, it's very hard to cut it. So this is why you cannot react CF with another reactant. They are quite stable. Okay, CH bonding also bad leaving group. Okay, Lg means leaving group, fluoride is bad leaving group, hydrogen is bad leaving group. This is why hydrocarbon are very stable. What does it mean, hydrocarbon? Hydrocarbon means you have carbon, hydrogen only in the molecules. Okay, so for alkane molecules, okay, they are quite stable. Okay, there are not a lot of reaction which occur with alkane. Okay, only cracking reaction or radical substitution with chloride atom. Chloride radical is possible. Okay, so alkane is very stable. Alkyl fluoride is also stable compared with another halogen and alkyl halogen. Okay, so this is bad. Sn cannot occur with CF or CH bonding. Okay, so the starting material must be alcohol or alkyl halide. So first, you must have a good leaving group. Second, you must have a good nucleophile. Okay, so what does it mean, good nucleophile? Which species are nucleophile? Rich electron. High electronegative, so the same here, halogen for example. Okay, so nucleophile must be, for example, good nucleophile. Could be an ion, for example. For example, chloride, negative charge, bromide, negative charge, iodide, negative charge, or oxygen, negative charge. It's possible also, for example, OH, negative charge. So this is called hydroxide ion, for example. And what else could be a nucleophile? It could be a lone pair. Okay. This is very important too. For example, nitrogen with lone pair. Okay, oxygen with lone pair. They are also good nucleophile. Do you know how to count the lone pair of nitrogen and oxygen? In which case, nitrogen has lone pair and oxygen also. You have to know how to draw the Lewis structure. Okay. We can spend 5 minutes to explain this one about the lone pair, because I see that most of people don't know how to count the electrons. Okay, we focus on nitrogen and oxygen. Okay, just break from this reaction. I focus on nitrogen. How many electrons? Valence electron of nitrogen? 5 electrons. Okay, so you have many possibilities of the bonding of nitrogen. Okay, so in general you have nitrogen with 3 sigma bonds. Okay, when you have 3 sigma bonds of nitrogen, how many lone pairs? 1. How to count the lone pairs here? Because you have 5. Okay, 1, 2, 3, 4, 5. For example, ammonium or ammonia. So in the molecule of NH3, nitrogen has 1 lone pair. Okay. Another possibility could be double bond, single bond. In this case, how many lone pair? 1 also. 1, 2, 3, 4, 5. So 1 lone pair. Okay. How about ammonium ion? Of course, this one is not complete. How many lone pair of nitrogen center? 0. Nitrogen follow octet rule or not? Nitrogen ไม่ออก Really? What does it mean octet rule? 4 arms. 4 arms. Nitrogen can have more than 4 arms. Really? No. So how many lone pair here? 0. Yes. 1, 2, 3, 4. Is it possible for electrons for nitrogen? Yes, but this nitrogen must have a positive charge. So ammonium, to be correct, ammonium ion. This is ammonium ion, positive charge always. Okay. What else? You have you rarely see this one, huh? Also triple bonds, lone pairs or not? How many lone pairs? 0. 1. So this is not possible. How about this one? This is possible? Nitrogen, not big. Not big enough. Nitrogen, triple bond, single bond. Why not? You follow octet rule because you have 4 arms. Why not? Yeah, why not? But it must be positive. 1, 2, 3, 4. What else? I think that's all. Nitrogen can be negative or not? Why not? But I never say this, huh? To follow the octet rule, okay? You can have, for example, 2 single bonds, 2 lone pairs. But of course, I never say this one. 1, 2, 3, 4, 5, 6. So this is negative 1. I never say this. But it's not, it's correct, but I never say this. That one. About oxygen. Oxygen, okay, because you will see a lot of oxygen stuff. In 0, oxygen have double bonds, okay, but it's not all the case. How many valence electrons for oxygen? 6, okay. So in 0 you can see oxygen, for example, oxygen of alcohol, OH group, okay. You have 1 single bond here and 1 single bond here. How many lone pairs of oxygen? When you have 2 single bonds of oxygen, how many lone pairs? 2. 6, okay. Good. You can have more than 2 lone pairs. But it's possible to have 3 lone pairs of electrons for oxygen. It's very easy, yeah? So you see a lot of this stuff. 1 single bond, okay, and how many lone pairs? 3. And this must be oxygen with negative charge. Okay, for example, OH, okay, is broken, so you produce proton and oxygen with a negative charge. And what else about oxygen? Okay, for example, oxygen of carbonyl group. This is carbonyl group, okay? How many lone pairs? 2, always. What else? Why not? I need to be like that. So, what happened with this oxygen? 1, 2, 3, 4, 5. I can put 1 more lone pair. 1 more? No. Oxygen is also tetravalent, okay? If we put If we put one more lone pair, you can start one. So this is a positive oxygen. Triple bonds. Start. So, how many lone pairs? And what is the charge? Yes. For example, hydrogen ion. Hydrogen ion is produced from water and protons. Once you solubilize acid in water, you always get hydrogen ion. So that's all. And how about carbon? The carbon isอะไรได้บ้าง carbon. Okay, carbon. Beta valence carbon. Okay. Carbon is very stable with 4 arms. Okay, how many valence electrons for carbon? This is the basic of organic chemistry. 4. Okay. Do you have double bond? Yes. Carbon double bond, 2 single bonds. Okay. Carbon with 2 double bonds. Carbon 1 triple bond. Okay, they are all basic. Okay. Is it possible to have carbon positive charge? Yes, it's easy to have carbon positive charge. For example, carbon with 3 single bonds. For example, so in this case, you have 1 free orbital here, and this one also. It's all sound. Oh, but it's very rare. It's all sound. Why not? And what else? How about carbon negative charge? This is possible? How to get carbon negative charge? No. 3 single bond and 1 lone pair. This is called carbon. And this is carbocat ion. Okay, but carbon ion is rarely observed. Okay, because carbon has low electronegativity, so it's difficult to produce carbon with a lot of electrons. It's not stable. Okay, so question is the basic of organic chemistry. And you have to understand how to count electron, how to count the charge. So carbon, nitrogen, oxygen follow octet rule. But how about sulfur? Phosphorus, for example. Sulfur, phosphorus does not follow the octet rule. Huh? So this is why you have more than 4 arms for sulfur, phosphorus also. So which atoms follow octet rule? Only the second period in the periodic table. I think something that has talked about octet rule before. I know. Octet rule is the basic of chemistry. Huh? Seriously, do you know octet rule? Octet rule. Yes. Maybe blank. Okay. So come back to our class. Huh? SN reactions. Okay. So SN reaction occur with carbon which contain heteroatom, okay, OH or X group with a good nucleophile. So good nucleophile could be anion, okay. So sometimes it could be carbon negative charge also. If you can produce carbon negative charge, a lone pair. So also, if it's possible to produce carbon with lone pair, but it's not easy. Okay, so in general, you see oxygen lone pair or nitrogen lone pair. So you can substitute. Okay, so this is how to write the mechanism. Okay, mechanism of SN reactions. So focus on the top here. Okay, I will show you how to react. Until halide, okay, with nucleophile that I don't identify. But this nucleophile contains one lone pair. Okay, so how to substitute halogen by this nucleophile? Okay, so the transfer of electrons must start from nucleophile species because nucleophile is rich in electrons. So in this case, these two electrons move toward carbon. Okay, so I use the two-head arrow because I want to show up the transfer of two electrons. Okay, in this case, two electrons move. Okay, in chemistry we call this is the attack of nucleophile on carbon. So the nucleophile attack carbon. So what happens with carbon? You have to break the own bond always because carbon has only 3 arms. You have already 3 here. So you can break this bond. How to break this bond? Halogen, okay, is the leaving group. So halogen quit the molecules by recovering 2 electrons of the single bond. Okay. So the 2 electrons of the single bond leave with halogen. Okay. So you have this product. How about halogen? You have 2 electrons here. Okay. So halogen, sometimes halogen is negative. But in this case, you want to negative to balance. Okay. Okay. So this is the general mechanism of SN reaction. I will give some example of SN reaction. Okay. So this is the new bonding. Yeah, finish. โอ้ยไม่ใช่นี้อะไรเนี่ยโอ้ไม่ใช่โอ้ตายเปิดokay. So the LV means living groups, okay, OH or X, etc. You substitute living group by nucleophile. So that's why we call nucleophilic substitutions, okay. So this is the example of until halide, okay, and nucleophile. In this case, nucleophile is an ion. So we substitute, you attack carbon by 2 electrons here, and you break the bond. So halide leaves the molecules by containing a negative charge. For example, okay. You have 2 types of the mechanism in SN reactions. Okay, the first one is called SN1, but SN1 contains 2 steps, but we call SN1. The second one is SN2, but in SN2 you have only 1 step. It's very strange. I will explain why. Because of the kinetic of the reactions. Okay. So in SN1, the starting material. So we focus on until halide. Okay. So until halide means untamed, which contain halogen atom. X could be chloride, bromide, or iodide. Okay, the 3 compounds. So you have until halide. The bonding, the single bond between carbon and halogen is polarized. You know what does it mean polarized of the bond? You have a partial charge I say partial charge because it's not the charge, it's not positive or negative, but the bonding between carbon and halogen have a little bit charge, a small charge, because carbon has lower electronegativity than halogen. Okay, so this bond is polarized. We call polarization of the bonding. Okay, you have a slightly positive charge on carbon atom. Okay, and slightly negative charge on halogen atom. Okay, so in this case, okay, the first step of the reaction can occur by the cleavage of the single bond between carbon and halogen. It just occurs, I will explain why. So, halogen as a good living group just quit the molecule at the first step. Okay, halogen has higher electronegativity, so halogen takes all electrons. Okay, so halogen takes 2 electrons with him. That's why halogen becomes negative. And how about carbon? Carbon lost electron, right? Because of this bond cleavage. So carbon lost 1 electron to halogen. This is why carbon becomes positive. This species is called carbocation. Okay? And the carbocation undergoes the attack of nucleophile for the second step. Okay? The transfer of 2 electrons from nucleophile to the carbon positive charge create the new bonding. So you have the product of the substitution reaction. And for the second type of the mechanism, SN2, everything happens at the same time. I mean, nucleophile attack carbon and halogen with the molecule at the same time. And you get also the product of the substitutions. So the question is, sometimes you have SN1 and sometimes you have SN2. It depends on what? It depends on the conditions. It depends on the starting material. Okay. It depends on how this carbocation is stable or not. Okay. This species is called an intermediate of the reaction. Okay. Intermediate of the reaction means some species can occur during the reaction, but it's not stable enough to last long. Intermediate of the reaction must be converted certainly to the final product. Okay, but it just occurs at one moment in the reactions. Okay. If you have a stable carbocation, the SN reaction must occur in SN1. Yes. When this carbocation is stable, but in sometimes carbocation is not stable enough, so SN1 is not possible, so SN2 occurs. Okay, but how to know the stability of the carbocation? Okay, I want to finish the substitution reaction. Okay, so it depends on. I want to talk about the stability. Okay, so SN1 occur when you have this type of the starting material. What does it mean R group? This and Q group. Okay, so we CH3, CH2, CH3 for example. Mean hydrocarbon group. When you have a lot of hydrocarbon substitute to the carbon, okay, you must have SN1 because once you produce this carbocation, okay, this is stable. Okay, but you have SN2 when you have only one and Q group substitute to the carbon, because this carbocation is not stable. Okay. And we talk about the stability of the carbocation later. Okay. And not forget it. Okay. So I show you this table because I just want to show you that you have different possibilities for the SN reaction. This table shows the starting material and the nucleophile, okay, and also the product. You can produce many final products from uncut halide, CH3Br. This is methyl bromide, okay, that one. So if you have methyl bromide as starting material and you react with, for example, hydroxide anion, you can produce an alcohol. This is the structure of the product. Okay, you substitute bromide by OH negative charge. You can react with methoxide, for example, methyl oxygen negative charge. This is called anhoxide anion. You produce, this time you produce not alcohol but an ether. Okay. What is the difference between alcohol and ethers? Hydroxyl group for alcohol and OR group for ethers. Okay. Okay, you have many possibilities. Sulfur with negative charge. This is also a good nucleophile. Carbon with negative charge. Okay. Nitrogen with a lone pair. For example, ammonia. This is very good nucleophile too. Okay, because this nitrogen contains one lone pair. Even water. Okay. Water is also a nucleophile because oxygen contains two lone pair. Sorry. And this lone pair can react like a nucleophile. Okay. So you can produce ammonium ion, for example, ammonium product from methyl bromide if you react with ammonia, for example. Okay, but of course, if you understand the reaction, how the reaction occurs, and how to write the mechanism of reaction, you don't need to memorize all this stuff. But if you don't understand what happened in reality, you have to memorize all this. Okay, if you react water with uncut halide, the product must be alcohol, but you don't know why, right? Okay. So once you go home, I hope that you try to understand the mechanism of the substitution reaction. And even I change the reactants, I change nucleophile, or I change the starting material, you can give me the correct product. Okay? Okay. And about the nucleophile species, you have what we call good nucleophile and a bad nucleophile. Okay? It depends on the nucleophilicity of the species. Okay? Nucleophilicity is the ability to be nucleophile. Okay? So you have the good nucleophile, for example, anion. Okay? Anion are good nucleophile, but when you have lone pairs of electron, for example, sulfur with lone pair, nitrogen with lone pair, for example, they are quite only moderate nucleophile. So not as good as OH negative charge, oxygen with negative charge, for example. Water, alcohol, or carboxylic acid are also nucleophile because of the lone pair of this oxygen. Okay, but they are just a poor nucleophile, so not that good. Okay, and the structure of uncut halide. Okay, as I say, this one. This uncut halide has 3 uncut groups on the carbon. Okay, so this one. When you have this type of the starting material, you have SN1 because of the stability of the carbocation. Okay, this uncut halide is called tertiary uncut halide. Okay, And when you have only two uncubed group substitute on the carbon, this is called a secondary uncubed halide. And only one uncubed group, this is called primary. Okay. So the tertiary carbocation is the most stable in general. Okay. So, but I don't think that I will ask you which mechanism. I will not ask you which one is substitution reaction, SN1 or SN2. Maybe it's too much difficult for you. But just to know, okay? Okay, and how about the living group? Fluoride is not good living group, you see, because of the strength of the body. Okay? But iodine, bromine, chloride are very good living groups, and also water. Okay, so what happens? How do you get water as living group? For example, you have alcohol. Okay. Water is very good living group. But how to produce water? You can start from alcohol, for example. And if you have starting material as alcohol, you can use acid as catalyst. Okay? What does it mean, acid? Acid is the compound which donates proton. Okay? So proton or hydrogen with a positive charge, this is called proton, comes from acid catalyst. Okay? So you can put a small drop of acid compound in presence of alcohol. Okay, so what happens? Alcohol will protonate. We call protonation of alcohol because alcohol takes this proton. I use the arrow again because take proton means these two electrons is transferred again. So you produce this species. What is the charge? Okay, these two electrons. Okay, these two electrons are this lone pair. Okay, so what is the charge on oxygen? Positive one. So you have this intermediate, and once you react with, for example, chloride, negative charge. This is a nucleophile. Okay? Nucleophilic substitution can occur very easy. You substitute. So oxygen positive recover 2 electrons. So you break this bond. Shoot like this. Okay? And you produce chloro and chloride. Okay? And how about the living group? Yes, and water. Water is byproduct in this case. So, if you want to perform a substitution reaction with alcohol as a starting material, for example, okay, you must use an acid catalyst. Without acid, it does not work well. Okay, because of this mechanism. So acid can change OH group to the better living group. To water. Water is better living group. This is a very, very good living group. This reaction is SN reaction. So nucleophile chloride anion and OH is living group. But OH is not very good living group without proton. Okay? So you can catalyze the reaction by using an acid to change OH to water, which is better living group. Okay. So you see OH negative is not very good living group. Okay. Okay. I think I will skip the role of the solvent now. It's not really necessary. So I summarize here about the SN reaction or nucleophilic substitution. For the primary and Q halide, okay, SN2 is favored, but for the secondary and tertiary, you have more chance to have the SN1 because of the stability of the carbocation. Okay, let me explain next time why tertiary carbocation is more stable. Questions? I think I will continue next time for elimination. But I have time. I have 30 minutes. ทำไมเรียนกันน้อย You know what time it is, you know? It's only 12. Yeah. I think a bit more. Okay. Just ask you from high school, I'm sure that you study about elimination reaction and addition reaction. Why I put them together? Because I modify a little bit my slide so you can put it. Because elimination is the inverse of addition. Okay, so addition is the inverse of elimination also. So I give you a brief overview about elimination reaction. Okay, just a little bit. So the first reaction was substitution reactions. So what does it mean eliminate? What is the meaning of eliminate? Get rid of, okay? So you have AB. The difference between substitution and elimination is in substitution you eliminate only one atom and substitute or replace by another atom, okay? But in elimination you don't substitute anything. You eliminate two atoms. Okay, so you have to eliminate two atoms from the starting material. So what is the product? Once you eliminate AB from the starting material, how about the product? C, the bond C. So this is called elimination. Okay. So elimination produces olefin. Okay. So you have to understand this reaction, how to produce double bonds in chemical, in chemistry. In organic chemistry, you can produce double bond by elimination reaction. Okay, so this is elimination. So the opposite of elimination is just this part. You have double bond. Okay, and you react with another reactants. You add two atoms to double bond. So what is the product? Alkane. So you convert back to the bond. Okay, so the first one is elimination, the second one is addition. So easy, so hard finish. So that is so easy. But there are different types of elimination reaction and also for addition reaction also. We use elimination reaction to produce alkene. Okay? Or olefin. But we convert alkene to another compound by addition reactions. So for elimination and addition reaction, we focus on double bonds. Okay? Okay. I think it's enough for you, huh? Right? So next week, okay, I will finish elimination and addition. I hope I can go for very fast next time because I have no need for the introduction anymore. So I will go pretty fast. So I just ask you to repeat at home about the vocabulary, okay, the different type. What is the meaning of nucleophile? What is the difference between nucleophile and electrophile, for example? Okay, why? Sometimes you have homolytic cleavage, but sometimes you have heterolytic cleavage, for example. And what is the meaning of mechanism? Why we can use two arrow, and why the direction of the arrow is like that, for example. You can try to draw the mechanism of SN reaction at home. Huh? Okay? Okay, so question? Don't worry. Okay, next time you will get used to this class. Huh? I hope that I don't scare you too much today. Okay. So hope that you come back next time. So next time I start 9:30. Okay. This room, yes, you don't like? So bring a blanket or something at home.